All right, let's break down the architecture for StatsX, a super high-performance alternative to Unreal's gameplay ability system.
This thing is built from scratch. It's all about maximum speed and efficiency for really complex gameplay.
So how does it actually pull off that native speed? Well, it all comes down to its core philosophy. Everything is built on 4 core principles. First up, a zero allocation hot path. Super important.
It's also designed to be cache line aware, fitting its data perfectly with modern CPUs.
Third, its lifecycle is handler-driven. Basically, no persistent effects are created unless you ask for them.
And finally, it turns visual graphs into compact bytecode, so you get ease of use and native speed.
This whole philosophy is organized into 5 distinct layers. Each one only depends on the one right below it. Okay, to make sense of how these layers work, think of a recipe, a chef, and a saved dish.
So, the recipe is your status definition. It's a data asset that gets compiled from the visual editor.
In the chef, that's the Forge VM. It's a super efficient virtual machine that just executes the recipe.
Now this is cool. The VM uses a temporary scratch pad and only makes a saved dish for persistent effects.
This whole setup gives us 2 ways to run things, a default fire and forget mode and one for suspended effects.
The memory model mirrors this perfectly. You've got transient memory for execution and persistent memory for instances.
So how do instructions know where to get their data? It's brilliant. They just use a simple source flag.
So, here's the key takeaway. The VM itself is stateless. All the persistent data lives completely outside of it.
So why should you care? Well, you get native speed, predictable performance, and way less garbage collection pressure.
This whole approach really makes you wonder, right? Is this the future for high-performance gameplay systems?